All right, IB Math SL students, here we are on problem number 7, and I will just let you know up front that this one is a doozy. So let's go ahead and dive in. We're given a function, it's an exponential e to the something with a trig function in it, for x greater than 0. So the first thing that I did was I went ahead and graphed this. So I typed in e to the 2 sine pi x over 2. I chose a window that I knew would work. In case you're wondering, here's what it is. I have my x going from negative 0.5. It could go from 0. In fact, I'll just make it go from 0 to 16. My y value, I think I'll have go from 0 to 10 is fine. And I'll hit graph. Please notice that I am in radian mode. That's rather important. If I was not in radian mode, I'd be in trouble. Okay, so you'll notice that this is kind of just repeating, which is not surprising because it has a sign in it. Now, you'll notice that it's asking us about maxima points. So here's the first, second, third, fourth, and so on, maxima. And so I could think if I keep going further, I could find the nth, or in this term, or in this case, the nth or kth maximum point on the graph. All right? And it has x-coordinate x subscript k, where k is a positive integer. All right, I believe it. Now it says, given that x of k plus 1 equals x of k plus a, find a. Well, that's a fancy way for them to ask us what the period is. So to do that, all I need to know is the distance from here to here. Well, I could find it graphically with a calculator, but I don't think I'm going to do that. Instead, I'm going to use I'm going to use math to do that. By math, I mean I'm going to solve it analytically. So I know that the periodicity comes from this term up here. So I'm going to define the period. Recall, that's equal to 2 pi over the number in front of the x. Well, that is pi over 2. Notice the pi's cancel, and I get 4. Now, I'd like to check that just to make sure it is correct, but let's go ahead and check it. I think that I'll just hit trace. So let's get over here. I'm about at the peak. That's somewhere close to 9. And so if I go to the next peak, I should be somewhere close to 13. And so as long as I'm close, yep, that's pretty doggone close. So I'm going to be happy with my answer of 4. Now it says, if that's the case, find the value of n such that the sum of all these x coordinates is equal to 861. Well, that's interesting. So first off, notice that I'm going to plug in a 1 and then a 2 and so on, right? However, before I get there, I'm going to notice the following, that maxima will occur when we have the sign of pi x over 2 equal to 1. Because again, that's going to be the maximum value of sine. So remember that the sign is equal to 1 whenever this thing is equal to pi halves or some multiple of that. So this will occur when x is equal to 1, because then I'll have pi over 2. And then if I go around the unit circle, I better draw a unit circle here. So here's pi halves. And then if I add 2 pi, that's going to be 5 pi over 2. And then I'm going to go around another full circle, and that will be 9 pi over 2, and so on. So I'm looking for this pattern where x equals 1, 5, 9, and so on. Well, that's going to occur. I get this pattern if it's just an arithmetic sequence that is equal to, I'll write it as 4k minus 3. Notice if I plug in a 1, I get 1. If I plug in a 2, I get 8 minus 3 is 5. If I plug in a 3, I get 12 minus 3 is 9, and so on. And this is for k equals 1, 2, 3, and so on. All right. So really, I'm looking for the following sum. I have, let's move this up a little. Okay, x is equal to 4k minus 3 from k equals 1 to n, and that's equal to 861. So it's sneaky. They actually turn this problem into the sum of an arithmetic series. So I will set the sum for an arithmetic series equal to, remember it's n divided by 2 times 2 u1 plus d times n minus 1. And you can find that formula in your equation packet. So the left-hand side becomes 861. The right-hand side, I don't know what n is, so it's n over 2. u1 is just equal to 1, so that's 2 times 1 is 2, plus d, well, I'm going up by 4 every time, times n minus 1. All right, this turns out to be a quadratic. Let's go ahead and solve it a little bit further. 861 equals, I can factor a 2 out of the top, so then I'm just going to get n times 1 plus 2n minus 2. And so if I simplify this a bit more, it looks like I'm going to have 2n squared. 1 minus 2 is minus 1 times n is minus n. And then I'll move the 861 over, so there's a minus 861. Now, I do not suggest trying to factor this. I used our handy-dandy polysymbol 2, and I got 21 and negative 41 halves. And obviously, negative 41 halves doesn't even make sense. So, I got an answer of 21, and that was a very challenging problem, but fun nonetheless.